All right, welcome to this big chungus of a video. Do not fear, this whole video is not for you. If you look in the description or the comments or somewhere, there should be timestamps for when your class is starting. This is basically a Friday video for if you would have been in class, and this will also work as just a simple review video for some exam stuff. So we're going to start with pre-calculus. So assuming that the only people watching right now are pre-calculus students, hi, welcome back to pre-calculus. So happy to have you today. First thing that we're going to see on this exam was variation. So let's talk about some examples of how you might see a variation problem. And we'll keep this running speedily, and you can rewind it if you get stuck or if you don't understand what I did. Let's say A varies directly as X, okay? We said way back in the day that varies means equals, so you always should know that this means A equals. Directly means multiplication, so we're going to have X times something, and what is that something? It's K, because in variation you're looking for the constant of variation, which is K. Now let's say it said B varies indirectly as Y. Well, B varies, B equals. Indirectly means division, and division involving Y. So before we said K times X, now we're going to say K divided by Y. So this is indirectly as X. Now what if I said A varies directly as X and indirectly as Y? So what if we had A varies directly as X and indirectly as Y? Then we'd say A varies directly as X, which means Kx, indirectly as Y, which means K over Y. So you'd end up having this sort of combo problem. Now let's look at this problem. B equals K over Y. What if I said that find K when B equals 5 and Y equals 2? Well, then I just plug my numbers in. 5 equals K over 2. How do I solve for K? Multiply both sides by 2. I end up with K equals 10. Now what if I said, now Y equals 17. Find B. Well, now I just take my original problem, which was B equals K over Y. I now have a new K, and I now have a new Y, so I'm going to plug these two numbers in. B equals 10 over 17. And then if you type that in your calculator, you will get a decimal value that will be your answer. Yay, smiley face. That's variation. Congratulations. That's everything you're going to see on the exam. Let's talk about the next topic, which would be derivatives. So, for derivatives, you might see a problem like this. F of x equals 6x to the 6th plus 3x plus 1. Then I would ask you for the derivative. I might ask you for, remember, this would be the first derivative, second derivative, third derivative, fourth derivative, fifth, sixth, seventh, eighth, ninth, 10th. Yay. For this problem, I'd probably ask you for like the third derivative. That means that we can take a shortcut and say, what exponents do we have that are less than 3? Well, this is x to the 1, and this is x to the 0. So taking the derivative, this is going to end up deleting both of these terms. So the only one we have to worry about is this guy. So we'd say 6 times 6, and I'm going to get my calculator out. We'd say 6 times 6 gives us 36. So that's 36x to the 5th. That's the first derivative. Then we do it again. 5 times 36. That gives us 180. So we'd say second derivative is 180x to the 4th. Then we'd multiply it again. 4 times 180. And we get 720x to the 3rd. And that is our answer. Okay, now let's talk about those trig functions. So if I had f of x equals, let's say tangent, and let's say 2 tangent of 5x squared plus x. These are the ones that we were having some issues with. And for a trig function, I will never ask you to do more than the first derivative, because that would just kind of cause some glitchy kind of mess. So, oops. Drop my pen. The derivative of 5x squared plus x. 2 times 5 gives me 10. Drop the exponent by 1. x to the first. 1 times 1 is 1. Drop 1 to the 0. There's no more x's. This is 10x to the 1, 10x to the 1 plus 1. So this is going to get multiplied by this 2, which would give me 20x plus 2. Tangent. No, I'm sorry. What's the derivative of tangent? It's secant squared. So that secant squared 5x squared plus x. The end. So what are the two main pieces for these trig functions? You need to make sure this turns into that. And you need to very much make sure that this stays that. And you need to make sure that you multiply the derivative of this term by the coefficient of the trig function. That's really all there is to derivatives. I don't know how much more in depth I can go. So we're going to move on to the next topic, which would be integrals. So if you're taking an integral, let's say I gave you f of x. I wouldn't write it like that. I'd just say, take the indefinite integral of 5x squared plus 3. Integrals are where you say, okay, I have the exponent of 2 here. I'm going to raise it by 1. And I don't have an x here, which means I have x to the 0, and I'm going to raise that by 1 as well. Then I'm going to rewrite the problem. I have 5x to the third plus 3x to the 1. I divide both terms by the number I find the new exponent. So 5x to the third divided by 3, 3x to the 1 divided by 1. And I just finished taking the integral. Yeah. So let's say I had take the integral of 4x to the 8th minus 8x to the 5th plus 0. Well, I'd say 8 plus 1, 5 plus 1, 0x to the 0 plus 1. So I end up with 4x to the 9 minus 8x to the 6th plus 0, because that's still plus 0, so this doesn't even matter. Then I divide this by 9, and I divide this by 6. I can reduce this guy, and once I do that, I'm done. Now, here's where the integrals took a bit of a shaky turn for most people, and it's when we introduce the definite integrals. Let's say from 0 to 2. And let's say the integral I'm taking is 3x to the third minus 9. So what this means is, first, I have to take the integral like normal. 3 plus 1. This has an x to the 0 plus 1. So I have 3x to the fourth minus 9x. With the definite integral, I have to plug in this for x minus this for x. So I'm going to write 3x to the fourth minus 9x, but with 2 in the place of x. So 3, 2 to the fourth minus 9 times 2. Whatever this number is, minus the same thing, but with 0 instead of 2. Minus 3 times 0 to the fourth minus 9 times 0. Now, lucky for me, I know this is just going to be 0. Because everything times 0 is 0. So I just have to figure this out. 2 to the fourth is 2, 4, 4, 8, 8, 16. And 16 times 3 is 48. So this is 48 minus 18. So this is going to give me 30. So 30 minus 0 is 30. So this is the answer to my definite integral problem. And of course, you're going to probably use your calculator for this. And we'll discuss how that exam is going to go next week, because I haven't quite figured it out yet. That's integrals. So we've covered variation, derivatives, integrals. Let's talk about limits. So I have a graph. 1, 2, 3, 4, 1, 2, 3, 4. Let's say my point is right here. And don't worry, Mikius, I will make it very obvious where your point will be on the test. I finished it yesterday, and it is very obvious. 1, 2, 3, 4. Let's say we have an invisible line back here. And this stretches, woo, and then it goes, whoa. All right, so the first question, how many different points of interest do we have? In other words, how many things do we have on this picture that are not standard? We've got this guy, and we've got this guy. So we've got an asymptote, a vertical asymptote, and a non-existent point. So I'll give you two different types of questions I could give you. as x approaches, in other words, as I'm moving left or right, let's say as x approaches this, 3, my function is going to be what? So, and let's say it's from the left. So I'm going to look at this point as x equals 3. So I go 1, 2, 3, and then look at what the point is there. It's right here. So as I come into this point from the left side, swoop, what is my y value getting closer and closer and closer to? It looks like it's at 1, 2, 3. So as x approaches 3 from the left side, the y value is getting closer and closer to 3. I could also ask you, what is x approaching as the function is approaching positive infinity? So I look at the graph at where it's stretching up forever, and it's obviously right here. So as my y value is going up and up and up, what is the x value it's getting closer and closer and closer to? It's this invisible line that it can't touch, but it gets closer to, and this is at 1, 2, 3, 4, -4. So as x approaches -4, it's going to be positive infinity. Now, this isn't necessarily always true, because what if I had this? Because now, as x is going closer to -4, it's not always going positive infinity. So if you're going to go to positive or negative infinity, you're going to have to tell me from what side. So this is coming in from the right side, so I need to say plus. So please make sure you do that, or it will not be correcto. And if you have to end up typing this, you would just type it in as -4 plus. You don't have to do the superscript. All right, let's say we had, well, that kind of covers everything. I think you've got enough stuff in your notes about limits. Let's move on. Let's do a calculator thing. Let's say you had f of x equals -3x, I think it's more fun, to the third, minus 2x plus 1. And I'm asking you for any zeros, for a min, or for a max, and for a y-intercept. Well, the teachers are at the school now. I can hear them making weird noises. Don't think the teachers get on you guys about making weird noises in the hallway, but before you get here, I just hear, wah, wah. It's really weird. -3x to the third power. What are they doing out there? Minus 2x plus 1. So I'd graph it. I would hit zoom 6 because that will reset my graph to make sure I'm seeing everything normally. And it looks like I got fortunate, and it only hits the x-axis right here. So I can look for that point. So I'll start with the zeros, which is where it hits the x-axis. So I'll go second trace, 2 for 0. Now I need to make sure my little x cursor is to the left of that dot, hit enter. Now I need to make sure it goes to the right of that dot, and hit enter twice, and it should give me my exact point, which at this point is 0.40. 0.40. Merry Christmas. We're done. Now I have to find a minimum or a maximum. So I'm going to zoom in. Whoa, wow, what have I done? I'll be frank, I think I just broke my calculator. What on earth is happening? It's definitely broken. There we go. It looks like I made a mistake and there is no minimum or maximum. So I'm going to change this to a 2 just for the sake of showing you. There we go. So this is very obviously a hilltop, which is going to be a maximum. So I'm going to go second trace maximum. I will go to the left of that dot, hit enter. Go to the right of that dot, hit enter twice, beep, beep. And I end up with -0.3, 1.3. Yes, you must write it in ordered pair format with parentheses. And yes, it will be counted off if you write that it was a minimum and not a maximum. So make sure to be specific with that. Y-intercept. Y-intercept is super easy to find because it's literally right here. 1. All right. What else is there on this test? Variation integrals. We've got Euclid. We've got the trig functions. Make sure to know that sine is cosine, cosine's negative sine, all that jazz. Integrals, derivatives, trig functions, blah, 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 blah. Once again, I'm only getting my Euclid information from the sheet I gave you. So just make sure you study that Euclid information limits. There's nothing I can really do to work on geometry. I'll do one problem with you for geometry. So let's say I draw this. Then he goes out here, goes up like that. And then you can also see this. Oh, guys, check out that beautiful 3D drawing. Oh my gosh. Somebody needs to hire me. This is 10. Let's say this is 3. This side right here. Let's say this whole thing is 8 wide. And let's say that this little chunk right here is 4 wide. And what have I not given you yet? The depth. The whole thing is going to be 16. All right. So given a problem like this, you really need to split it into 2 pieces. So the way I'd visualize this is you're either going to divide it into this little top box sitting on top of a big box. So like there's 2 boxes sitting on top of each other. Or you could set it as there's a long rectangular box sitting next to a smaller box. So you decide how to slice it. I'm going to slice it this way because it's how my brain works, but you may do it the other way if you'd like. So then we're going to talk about each shape individually. I'm going to start with the big chungus because it's easier. So the big box on the bottom is not 10 tall. It's 10 minus 3 because this bit is 3, which means this bit is 3, which means to get this piece, it has to be 10 minus 3. So this is 7. So big chungus is 7 times, it is 16 long times 8 wide. So 7 times 16 times 8, 7 times 16 times, gives me 896. So I have one number. Now we're going to look at the tiny box. Tiny box is 3 tall. It is 16 wide and 4 across. So 3 times 16 times 4. 3 times 16 times 4 gives me 192. Add these 2 numbers and I get my final answer. Use this video for your reference if you need to. And now, if you are in pre-calculus, your job is done here. Have a great rest of your Friday, and I'm now going to be starting chemistry. Getting a text from the 90-day fiance. All right, where's my chemistry stuff? If you're still hanging out just for no reason, I have this problem where I have my personal email and I have my school email, and I use both of them for Google Drive. And that's nice, except the problem that I can never remember where I saved things, because sometimes I'll make my tests and stuff on the personal Google Drive because I'm just happen to be logged in, and then I can't find anything. So I couldn't find the chemistry exam for a little bit. All right. So, hello, chemistry sufferers. This timestamp should have taken you to right now in the video. So, I have not yet figured out how I'm not modifying your exam in the slightest. Math exams are pretty easy to write for online because it's kind of hard to cheat on a math exam, because you have to show your work. But it's pretty easy to cheat on chemistry. So it's going to be some doing, but I'll keep you guys posted and in the loop as to what exactly we'll be doing. Hang on, maybe getting a visit from a Miss Moog. Oh, nope, there she goes. Bye, Miss Moog. So I would like to just do a quick review. Make sure you go over that vocab we went over. on the first study guide. I'm not going to re-go over that, but that vocab will rear its ugly head. So make sure you actually study that. I'll give you a little bonus just for watching this. I am going to ask you for the 3 laws of thermodynamics. So make sure you are able to summarize those. I don't want you to memorize the masterful chemistry level definition. Just if you can say like the third one, you can't reach absolute zero. I'm not looking for. It is impossible for scientists to reach absolute zero by creating false dichotomies and breaking the laws of physics. No, just right. Can't reach absolute zero. That's it. We covered that. Wow, is there anything new? Yes, okay. So we've covered everything, but I would like to just do a couple of the different kinds of problems just for you to be able to rewatch and get it glued into your head. So first thing, we had the Lewis versus Ionic. So let's say you had... Ooh, I did not prepare for this. Hang on, I'm gonna have to... Oh, sorry, awkward technical difficulties. I usually draw them first. And then once I've drawn them, I'm able to actually, okay, I got one. And that is not something I wrote in the test. Okay, this is going to be, let's say you had CH3, COH, CH2. Let's say you had this lovely guy. So, first question, would this be covalent or ionic? Well, I see a carbon, hydrogen, carbon, oxygen, hydrogen, carbon, wow. Carbon, hydrogen. All of these are covalent, which means this has to be covalent because they're all non-metals. None of them are metals. So I've got to try to draw this picture and make everybody happy. If they're written right next to each other, more than likely they are right next to each other. So I'm going to start with a CH3. Each H has 1 dot. Each carbon has 4 dots. I can connect them between these guys. And carbon has 1 spot left over, so that's where I'm going to put the next guy. I have a COH. So I'm going to put the next carbon right here and connect them. Now I have an OH to fit somewhere, so I'm going to put him down here just because there's more room. OH. So O has 6 dots. That means he can connect to the hydrogen, he can connect to the carbon, and he's got 2 lone pairs and is happy like that. Carbon now has 2 open spots. Let's see what I have left. CH2. So I'll write a C, 2 H's. Carbon has 4 dots. Each hydrogen has 1 dot, so hydrogens can bond here. Carbon can bond here. This is not satisfied because carbon has an extra spot and carbon has an extra spot. This carbon has 3 out of 4 bonds. This carbon has 3 out of 4 bonds. That means, I can move these electrons and squeeze them right here and create a double bond. And now carbon has 4 bonds, carbon has 4 bonds, carbon has 4 bonds, oxygen has 2 bonds, hydrogen, 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 all have 1 bond. This structure is happy. Now, let's say I had something along the lines of, let's say aluminum 3. No, that's going to be dumb. Aluminum 4. Ooh, spicy. So aluminum 4, oxygen 6. That should work. Let's see if it does. That means that I would have to say, there's a pair of brackets, Al, pair of brackets, O. I have 4 aluminums. I have 6 oxygens. My charge for aluminum is 3 plus. My charge for oxygen is 2 minus. 4 times 3 is 12. 6 times 2 is 12. This balances out. It's Gucci. Now, this seems a little too easy, and this is not what we did. That's because it's not. So the way I'd word this would be aluminum plus oxygen gives you what? And then we need to say, okay, aluminum has how many dots? 3. Oxygen has how many dots? 6. This connects there. This connects there. I'm out of spots. I need another oxygen. This connects there. I'm out of spots. I need another aluminum. I'm out of spots. I need another oxygen. I am now full. So technically, the simplest way to write this would be Al2O3, aka this guy would never exist because I made it up in my brain. This is the way it would exist because it fits normally. So then I would take this guy and write it as an ionic. So I'd have Al in the first box, and I'd have O in the second box. I found that I have 2 Als here and 3 Os here. Al's charge is still 3 plus, O charges is still 2 minus. So 2 times 3 is 6, 2 times 3 is 6, 3, 3, 2, 2, I'm good. Yay. There's an example of covalent and ionic. Let us talk about the possibility of you seeing something like formal charge, because nobody really liked formal charge, right? I would like to do, I know I did this in class, but I'd like to do it again because I think it's the perfect problem to show. I believe it was NO3 minus, or was it NO3 2 minus? Oh, you hear that, guys? That was the bell. I don't know if I'm actually supposed to be in here right now, but we'll see. If Miss Smith gets mad at me and comes in and talks to me, I don't know. We'll see. But this will be an adventure for all of us. So formal charge. First thing, I need to find how many electrons I have. So I have a nitrogen, an oxygen, an oxygen, an oxygen, and 1 electron that I see right here. So how many does each guy have? This is 1. Each oxygen has 6. Nitrogen has 5, so I have 6, 12, 18. This is 6 as well, so 6, 12, 18, 24. 24 electrons. Now I need to find how many lone pairs I have on my central atom. So I would have 24 electrons minus 8, which is just part of the equation. 8's always there. Times how many, so we're using nitrogen in the middle. So how many atoms are not in the middle? 3 different oxygens. So we'd have 8 times 3, all divided by 2. 8 times 3 is 24, so 24 minus 24 is 0, so that's 0 over 2, so that's 0 lone pair. So I have 0 dots on the middle of my problem. So now that I know I have 24 dots in total and no double dots on the middle, I can start to draw this. So I have a nitrogen, 3 oxygens, no double dots in the middle, which means nitrogen's going to have 4 bonds. And then I can just fill in the dots. I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I'm done and everybody is full. So I end up with a problem where now I can draw the little formal charge chart. I've got nitrogen and 3 oxygens. First, I write how many electrons, valence electrons, does each thing have. I already wrote these up here. Nitrogen's got 5, and all my oxygens have 6. Now I say bonds plus bonds and dots. So how many bonds does nitrogen have? 1, 2, 3, 4. How many dots are on nitrogen? 0. Let's do the top oxygens first. How many bonds? 1 and 1. How many dots? 1, 2, 3, 4, 5, 6, and 6. The bottom one. How many bonds? 2. How many dots? 1, 2, 3, 4. So now I have 5 minus 4, which gives me 1. I've got 6 minus 7, which gives me negative 1. I've got 6 minus 7, which gives me negative 1. And I've got 6 minus 6, which gives me 0. If I total all these numbers up, negative 1 and 1 cancel out. Negative 1 plus 0 is negative 1. And if this number matches my original drawing, which it does, I know I got my answer right. So again, I foresee these being the troublemakers if any problems are. What else will you see? I already need another piece of paper. So let's say you had, I'm making sure this isn't the same thing as a problem. Let's say you have BE2. Oh, that's not going to exist actually. BE3. N2. All right, so let's say we had to name this sucker. So if we had to name this, then that would be a metal and a non-metal, which means this is ionic, and if it's ionic, we don't use prefixes. So this would literally be beryllium. Oh no, how do you spell beryllium? Nitride. And that would be the end of it. Now, let's say we also had N2O3. In this problem, we would have a nonmetal and a nonmetal, which means this is covalent, which means we are going to use prefixes. So the prefix for 2 is di, the prefix for 3 is tri. So we'd have dinitrogen, trioxide. Now remember, we only use "ide" on the second word, not the first word. So let's say we had to find the oxidation numbers of these, because that's the last math-ish thing we're going to be doing. So we have Be3N2. So if we need to find the oxidation numbers of these things, what on earth are we supposed to be doing? We are going to follow our oxidation rules. So we say, all right, what rules say what? Are nitrogen or beryllium mentioned in the rules? Well, nitrogen's never mentioned in a major way, so we don't really have any rules associated with him. But we know beryllium in the periodic table is like right here. So he's in the second column. And we know that the second column, the alkaline earth metals are in charge of +2. So we know that this guy's supposed to be +2. So we have Be is supposed to be 2+. So if this is 2+ and we have 3 2+, what's the total charge? It's going to be 6+. Now, I don't have a number written up here, which means the charge is 0. So these nitrogens have to cancel out this 6+ to give us 0, which means they have to be 6-. So if we have 6- and it's split across 2 atoms, 6 cut into 2 would be 3. So each nitrogen is going to be 3-. And that's the answer. Now let's take the other one. Dinitrogen trioxide. Who do we have more information about on the rules? Nitrogen or oxygen? Well, best I can remember, oxygen has quite a few rules. Unless he's with Na2O2, fluorine, or H2O2, his charge is pretty exclusively going to be 2-. And we don't have a charge on this atom, so we know it's supposed to add up to 0. Oop, that didn't right. So something plus something equals 0. The oxygen is going to be 2-. We have 3 2-. 3 times 2- would give us 6-. So these nitrogens have to cancel out the 6-, which means they have to be 6+. 6+ split across 2 atoms would be 3+. So each nitrogen is 3+. And those are my oxidation numbers. So chemistry, I will be in touch about how we're doing this exam thing, but all we were going to review today were the more mathy problems. If you need individual help, feel free to reach out. On Monday or Tuesday, we're going to have a group Zoom call, but we can schedule individual ones as well if you need special help. This is exam week, which means my time is your time. So, bye.